We don't finish every single thing, but
Around there.
here we go.
Look at all the trees out there.
I know, that's too bad. Because all your other classes, you're doing every single page, right? So here we go. I agree. I'm not a fan of consumables. But what you do know has happened is in math, they're switching over to the new Common Core framework, and they really don't have that great of books out there yet. So we said, as number one, we've heard good things about this company. Number two, they're doing the integrated math, which we philosophically wanted to go to. And number three, we said, why spend a ton of money on books if we're not sure if we like it yet? So this book is like $18 each for you guys, whereas a regular book is more like $80 each. And so again, I don't like wasting trees either. We're going to digital next year with the Math 1, 2, and 3 is going to do the same system that Miss Morell did in Math 2. And again, I agree, we don't want to kill trees, but you know, sometimes you're stuck with what's available to you. And there were only really 2 programs at the high school level that had moved to integrated Common Core yet when we were shopping for a system or a book. So here we go. Are you ready? Oh, there we go. Good. We are on page 796, starting 14.1. Previously.
You determine the congruency of geometrical figures. Now you will determine the perimeter and the area of geometrical figures.
Okay, so we kind of took a break from the book while we were doing SBAC testing and those block schedules. So some of this you already know. We're going to be looking at perimeter and area of shapes, and you have a little bit of a head start on this. So here we go. Graph rectangle ABC with the following vertices. Go ahead, make the graph, please. After you graph the vertices, sketch in the shape. Number 1A, determine the perimeter. What's perimeter?
Outside.
The edge around the outside. Just this line, and we need to count. We need to start here and count boxes to the right, up, left, down. What's the perimeter?
14.
2 sixes is 12. How about the end?
2.
So this is 6, 6, 2, 2. Counting boxes. For grand total, if I add those all together,
13.
what do you say?
16.
16. Determine the area. It's a rectangle. How do we determine area? Base times height, so what do I need to multiply? 6 times 2. Area equals 6 times 2, 12. You with us so far? Okay, this hopefully isn't new. Number 2, Horace. Jerry, got it.
Horace says that he determined the area of the rectangle ABCD by determining the product CD and CB. Vernon says that Horace is incorrect because he needs to use the base of the rectangle and the base is AB, not CD. Forrest responded by saying that CD is one of the bases. Who's correct? Explain why the students, why the correct students' rationale is correct.
This sounds like a headache. Nope, let's move on.
Good idea.
We could do it, but
Go on to column
the
4.
perimeter and area of a rectangle.
What are you looking at?
I'm right above number 3, where it says the perimeter and
I
area.
gotcha.
Thank you, Andy.
The perimeter or area of the rectangle can be determined efficiently by using distance formula or by simply counting units on the coordinate plane.
Okay, analyze our STU, another rectangle. What are the increments of the x and y axes? What are the units?
We're going by 100.
Let's see, 1, 2, 3, 4. Nope, because I see 4 boxes makes 300.
Making 1 by 75.
What's 300 divided by 4?
75.
Okay, 75 per box. Okay, is it doing something different or the same on the y-axis?
What do you say?
1, 2, 3, 4 to get up to 300. Okay, so for A, for Christian, 75 per box. List some strategies you can use to determine the perimeter and area of the rectangle. What can we do for this figure? How about perimeter? How can we figure that out?
Add total. Add length.
How are we going to find the lengths? Count boxes. But are the boxes each one?
No, there's 75
Okay, so then you got to times
by 75.
by 75.
18 times 75.
And then you're ready to add sides. Okay. How about area? What do we need to do for the area? Area equals base times height. But before you do that base and height, you're going to have to do something similar. Count the boxes and times by 75 because each box was worth 75. Flip the page. Determine the coordinates of the vertices of the rectangle, then calculate the perimeter and area of the rectangle. So flip it on back. We need the coordinates of the vertices. We need the x and y. I'm going to make it bigger so we can look at it. Let's see. Right here, this side, T and S. I'm going to start with T for Tina. Put a big parenthesis. The x goes to 601 box more. On this graph, what does 1 box represent, Brody?
75.
75. So if I go to 601 box more, 675 is the x coordinate of T. Now it goes up. Oh, great. It lines up straight on a line. What is that, Christopher Bernal, on the y-axis? I look over to the y-axis, 600. Okay, S. Which coordinate is the same for S?
R.
Wait a minute. Which coordinate, x or y, could I just write down right here? Am I going to write 675 or am I going to write 600? 675 is the x coordinate and it hasn't moved right or left. It just went straight down. The y is going to be smaller though because S is lower down. Now I got to figure out what the y... And let's see. It's 300 plus 1 box.
75. 375.
And each box is 75. So 375. You guys do U and R. I'm going to walk around. Already got it, Brian. You can just write them on your sheet. You don't have to bring them over.
No, it's the
I stick with the first one.
Double check.
You know, it's always good to have a
Just
second.
finish, double check.
Now then, does she agree with your answer?
Each of them should have two. I only see one right there. You get them, Christian, double check.
Oh, yeah, I got that.
Okay.
When you guys put
No,
Okay, let's see what we have. Who's confident in their R?
Jerry is.
Jerry Man, what do you got?
I got 225.
225 and?
375.
Thank you. Do you agree with Jerry? Who's confident in their U?
Jerry.
Thank you, Memo. What do you got for you? 225 and 600. Good. Now we need to do perimeter and area. Let's go to the other side. We're going to have to flip back and forth a little. Perimeter. Area. I'm going to sketch it over here just to make life easy. A little easier. I know it is math class. It's only so easy. Now I'm going to flip back and count. How many boxes up? How many boxes over?
3 up and 6 over.
3 up and 6 over in boxes. Now what does each box represent though? 75. So we're going to go 75 times 3, 225. So I'm going to cross that out and put 225. And 75 times 6. What's 75 times 6? It's going to be double this, right? Because that's 3. What's double of 225? What's double of 200?
450.
And thank you. Good. 450. So that's our length and width. All right. For perimeter, I need to remember it's the same up here and over here. Those match. Now I got to add those all up, right? Perimeter is how far around the edge. P equals, you may use your phones as a calculator. You already did it? What do we get?
1,250.
Area. What do we got to do for area? We got to multiply them.
great for walking.
Somebody with a calculation device.
I do.
I think Ernesto's on it. I don't know. Jacqueline's on it too. Isabel.
Oh, hold on. Jeff wants me to check.
Isabel, did you do it?
I got 101,250.
Okay, good. There we go. Blah, 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 blah. Blah, blah, blah. I don't like what they're doing right there. Moving on to number 2. Or problem 2, page 801. I don't know if I really like this either.
I don't either.
I don't like
It's
it.
pretty confusing.
I got a better idea.
So do I.
I disagree. I think they should do it.
Videos.
Yeah.
If Mr. Craig was in charge